Good morning, class. So today we'll be learning about angle relationships and how we can use those relationships in order to find missing angle measurements. Okay, so in class, I have given you all a packet that has all of the definitions for angle relationships in them. During class, I went through multiple examples of those angle relationships, but for my people who may have missed school or are not in school, I'm going to briefly go through them before I go to like how we actually use them and apply them. So the first angle relationship, so the title would be angle relationships. So, to simplify, what that would be is how angles interact with each other, all angles, okay? So this applies to all angles in different aspects. So you'll use these relationships more than just in my class with math. Just keep that in mind. So knowing these relationships could help you in the long run. All right, so the first one, the most basic one, would be adjacent angles. Okay, when angles are adjacent, or the best way to describe adjacent angles is just talking about angles that are literally next to each other. So like, for example, if I draw a complex little device, right? All right, so there are a bunch of angles in front of us, right? So adjacent angles just describes and shows that angles that are one next to each other that share a side, okay, and usually share some type of vertex. So that's like a point where they connect. Those are adjacent angles, okay? So this angle over here and this angle over here are adjacent, all right? But if we look at a different direction, right, we could say that this angle in the green that was in the blue is adjacent to this angle over here, okay? So don't overcomplicate angles being adjacent. It's just saying that they are literally next to each other, okay? Very simple, straight to the point. All right, the next angle relationship that we can talk about would be a vertical angle relationship. I believe that's the next easiest one to comprehend. So vertical angles, or a vertical angle relationship, is just a relationship where, where you have an intersection, okay? So that means that's a point or an area where two lines cross, okay? That's what an intersection is. It could be two or more lines, but I'm just in this diagram, I'm showing you two, okay? Through that intersection, you have angles, right? So I'm gonna say we have angle 1, 2, 3, and 4, okay? Angles that are opposite of each other. So in this case, that would be, or it could be, angles 1 and 3, right? Or it could be angles 2 and 4. Those are known as vertical angles. What's important to know about vertical angles is that they are equal, okay? Meaning angles 2 and 4, whatever they measure, are equal. So if I say angle 2 is 30 degrees, then angle 4 is also 30 degrees, okay? Same thing goes for angles 1 and 3. Now, when you're looking at the different diagrams, trying to figure out if there is an angle relationship, be very particular with what you're looking at, because the angles should look like they're the same angle. It's just one's facing one direction, the other one's facing another. And like I showed you, they should cross some type of intersection of lines. Like the oppositeness should be across the intersection. Okay, so that one's very simple too. It's basically angles opposite of each other that cross an intersection and they measure the exact same amount. Okay, so now I'm going to talk about something that could be a little bit more complex, but not really, which would be using an eraser, complementary angles. Okay, I'm gonna talk about a complementary angle relationship. So, to give you word definition, a complementary angle relationship is where you have two or more angles who add up, so their sum is equal to 90. So basically, if I give you the definition in a nutshell, we know that a 90-degree angle is a right angle, okay? If this right angle is broken into pieces, right? It doesn't matter how many pieces you break it into, right? Because you could break it into, see, the first one is broken into 3 pieces. The second one I drew is broken into 2. You could break it into more. But regardless, if it is split in some type of capacity, that means it is made up of more than one angle, all right? But all of these angles still create that 90-degree angle. So that's what complementary relationship is, saying that these 3 angles, when I add them together, they make the 90 that they sit in. Same thing over here. These 2 angles, when I add them together, they make the 90 that it sits in. So to give you a better example, right? So let me say, I say angle 3 is, 45 degrees. Angle 1 is 20 degrees. And I need to figure out what angle 2 is. And then over here, I can say that angle 2 is 40 degrees. And I need to figure out what angle 1 is. So if I'm looking at them, I know that they have a complementary angle relationship because they are in a right angle. And I know a right angle because I see that square in the corner. Please do not assume that you have a right angle if you don't see the square in the corner. But there are other ways that you can identify that it should be a right angle if the square is not there. But you have to be very specific. We'll get to that when we get to our examples. So continuing with this, so since I know that if I add up angle 1, 2, and 3, it should equal 90. To figure out what's missing, or x, I would do 20, right? Plus 45 plus x should equal 90, okay? So then I would combine what I could combine, or combine my like terms. That would be 65 plus x equals 90. And then I know to figure out what x is, I would have to subtract 65 from 90, okay? Which would give me x is equal to 25, okay? So that's how you use complementary angle relationship to figure out missing angles. So of course at the bottom it would simply be 90 minus 40, which we know that this would equal 50, okay? So the biggest thing to remember with complementary is that the angles should make a right angle, okay? So they should be sitting in a right angle, and they add up to equal 90, okay? So then going forward, you have another angle relationship, which is supplementary. Okay. Supplementary angles. So just like complementary angles, you have more than 2 angles, 2 or more, that add up to equal something. So with a supplementary angle relationship, it's 2 or more angles that add up to equal a 180, okay, 180 degrees. The easiest way for you to find a 180 degree angle is that those angles will be sitting on a straight line, okay? That is the biggest hint. They will be on a straight line, or a half a circle. They're making a half a circle. I made a mistake and wrote 280 here. Let me fix that. Actually, go back. Try to do it a little better. But yes, they will make a straight line, meaning that they make a 180, okay? So just like with complementary, if I give random measurements, right? So let's say this one is 35. This one can be 40. I don't know what this one is. And then this one is like 30, okay? So I would need to figure out what they are. I know that since they have a supplementary angle relationship, they should add up to equal 180, right? So that would be 35, right? You don't have to put the degree sign. Plus 40 plus x plus 30 should equal 180, okay? So then I add up the things that are the same or like terms, so that would be 30 plus 40, which is 70. 70 plus 35 is 105 plus x equals 180. And then just like with complementary, of course, to figure out what x is, I would subtract 105 from 180 to give me that x equals 75 degrees. So that means this would be 75. Okay. So then down here, you're doing the same thing, but we're only using two angles. So now I need to give you another relationship rule you can find. So when you specifically have two angles that have a supplementary angle relationship, which means that they create a straight line, they can also be referred to or known as linear, a linear pair. Okay, so the reason they're called a linear pair is because, well, first off, there's two of them, because 1, 2, and second of all, they make a straight line. Okay, so linear pair falls under the category of supplementary relationships because it is specifically two angles that add up to equal 180. So to be more specific again, linear pairs can only look a certain way, which means that you can only have two types. You could have two right angles that make a linear pair, which means you have a 90 and a 90, or you can have an acute angle, which is an angle that ranges from 1 to 89, or an obtuse angle, which is an angle that ranges from 91 to 179. Okay, those are your two options for how linear pairs should look. Either they're both going to be right, or you're going to have an obtuse and an acute angle. There's no other way for a linear pair to look. But like I said, linear pairs fall under the category of supplementary, meaning that if I make this 55 and I'm trying to figure out what this is, I know that this x and 55 should add together to equal 180, meaning that to figure out what x is, I need to subtract it from 180, so x would equal 125, which matches the description that I gave you, because I know 125 degree angle is an obtuse angle and a 55 degree angle is an acute angle. Okay, 90 and 90 is easy because we know 90 plus 90 is 180. You should see the boxes in the corner. It says two right angles. Okay, so I'm going to go through real quick before I go to the work pages, like what we talked about with the definitions. Okay, so with angle relationships, we had adjacent angles, which was just talking about angles that are next to each other. We have vertical angle relationship, which is angles that are opposite of each other across an intersection should be the exact same angle, meaning that they should measure the same. We talked about a complementary angle relationship, where if you have a right angle, you know you have a right angle because you see the box in the corner. If it's split into multiple angles, those angles should add up to equal 90. And then now supplementary angle relationship, where we have a straight line that could be split into multiple angles, and those angles should add up together to equal 180. Okay, to talk about. Okay, I just wanted us to summarize where we were. The last angle relationship we have are angles at a point. Okay, so if I break down where we started, we did complementary, which was just 90. We doubled that and did supplementary, which is 180. And now we're going to double that and angles at a point. Of course, if you do 180 plus 180, that means you have a 360. So those are one or more, not one, I'm sorry, two or more angles. It's probably going to be definitely more than two. That add together to equal 360 now. Okay, so it's the same concept. You just have to know what it looks like. And so you usually have a point in the middle or an intersection point, and you have multiple angles that are out from them. So now when you have angles at a point, you do have the opportunity to kind of use other angle relationships with it. Like, for example, I could show you that if I was looking at this, I could kind of say that this angle and this angle over here might have a vertical angle relationship because they kind of look like they're the same. Of course, I'm drawing it freehand. It'll look more precise in the book, but like that's how you can use your angle relationships to kind of help you out. So if I do go with saying that they're vertical, right, that would mean that if I say that this is 30, okay, I don't put nothing in this space, but then I say that over here is like 65. This one over here is let's say 70, and then I want to figure out what X is over here. Okay, so I didn't give you this blank, right? But using something you just learned with vertical angle relationships, you can automatically fill this in with 30, which now helps you use angles at a point relationship where the 30 plus the 30 plus the 65 plus the 70 plus the X should all equal 360. Okay, so just as I did before, I would add up all my regular numbers on my like terms, which this would equal 195 plus X equals 360. I put 366. Then of course, you have to subtract 195 to get them to go away, and then X would equal I actually have to work this one out. 10, so that's 5 in the back. 2, 15. That would be 6, and then 165. So that means this degree is a 165-degree angle. Okay. So if you need to, please rewatch at any point in time me explaining the angle relationships. But that's what we're about to use to kind of do to definitely do lesson 1. All right, so go ahead and open your book to page 9 as I get there myself also. All right, so page 9 should look something like this. So they have an example for us. So I'll walk us through the example so we can kind of get an idea of what's going on, and I can explain a couple things with the example too. Okay, so first they give us the figure, which is usually the little angles and stuff like that. And of course we need to figure out something. We need to figure out what we don't know. Okay, so if you read what it says, so first of all, I like to say that this little sign above BE is reads line. So whenever you see this above some letters, that just says line. It says the word line. So if I read it, it's gonna say line BE. Okay, so line BE intersects. When you see this little description above it, it just says ray. So that would be line BE intersects with ray AC and ray AD at point A. Okay. So now, if I look at the diagram, I can see that that's very true because line BE is the line at the bottom. Okay. The ray AC would be from point A to C, and ray AD would be from point A to D, and they all intersect and cross at point A. So everything they gave me in the description makes sense. Just making sure that we can identify and verify these things on our own. All right. So then the next column says describe an angle relationship. So the reason we need to describe an angle relationship is so we can figure out what is missing. So if we look back at the figure, we know that this angle is 38 degrees. We know that this angle over here, because of that box in the corner, is 90 degrees, but we don't know what the degrees of this angle is, and that's what we're trying to find out. That's what we're accomplishing, okay? So now, if I go to the description they gave, whenever you see this in front of some letters, that just reads angle, okay? So it says that angle CAD, which would be from C to A to D, so this right here that we don't know, and angle DAE, which would be from D to A to E, which is what we know to be 38, are complementary. Okay, so now if we go back to our definitions and our classification of angle relationships, we can say that that means that this 38, okay, plus the 2x should equal 90, right? That's what we should be able to come up with. So now if we continue looking at the example, we can see in the example that is what they wrote as their equation. Okay, so they created an equation in order to be able to figure out and solve what they needed to in order to figure out the missing angle. And in order for us to figure out the missing angle, what we need to figure out is what x is, because x times 2 is what will give us that degree. Okay, so now if we go through their process, right, they subtracted this 38. Okay, so what they're doing now is called a process known as solving equations. Okay, when you solve equations, which we'll get into more into this in lesson 3, you need to do what's known as isolate the variable, which means you want to get the variable, which in this case is x, by itself in the equation. Okay, so in order to get it by itself, we would leave whatever's with x alone, like we don't mess with it, and get away all of the extra pieces and things first, and then come back and get rid of it. So since this 38 is positive or plus when it's trying to interact with 2 and x, to get rid of it, we would have to do the opposite, which means we would have to subtract 38, which is what you see happening. Since this is an equation, which means one side is equal to the other, in order to keep it equal or keep it balanced, we have to do the exact same process on the other side. Okay? So think about a scale. If I took 38 off of one, so if they were equal in the beginning, and I took 38 off of one side, the scale's no longer equal. I need to keep the scale equal when I find out what the variable is, or in this case, x, so that way I know that it should work in the equation that I started with, where it was equal in the beginning. Okay? So after they take 38 from both sides, that leaves you with 2x equals 52, and then now you need to separate 2 and x. In order to separate a variable from the number or its coefficient, which is the number that is in the front of the variable, in order to separate those two, you have to divide. Okay, the reason you're dividing is because 2 and x are trying to multiply. We just can't multiply them until we know what x is. So just like when it was positive, we did the opposite and subtracted to get rid of it or move it away. We do the same thing since they're multiplying. Since they're multiplying, we need to divide by whatever the coefficient is, which in this case is 2, to get rid of it. Same thing before, since we did that on one side of the equation, we also have to do it on the other side, which will tell us a final answer that x is equal to 26. Okay, so now that we know x is equal to 26, we can use knowing that x is 26 to figure out what this area is, which if we do 2 times 26, that will give us 52. Okay, And that's basically what we do with our different angle relationships in order to figure out the measurements that's missing. We have to first describe what we see. So we have to claim an angle relationship is going on that will help us get to our final result of whatever they're asking us to find. We need to write an equation for that relationship so that we can solve it to figure out x if we need to, or whatever variable. Then we use that variable to basically get our answer, or fill in, like, knowing what all the measurements in the figure are. Okay, so now that we kind of have a rough idea of what we can do and what we should be doing, I'll solve a couple of the problems and then kind of leave the rest for y'all to kind of play with. So we can look at number one. They give us a description of the figure, or they talk about the figure. The figure AFE, angle AFE is a straight angle. So being that it's a straight angle is just saying that it's a straight line, which means we know that it is 180 degrees. Okay, so that is what is very important about this. So now if we describe the angle relationship, right, we would say that since, or we don't put since, but we will put that angle, okay, AFB, comma, so that's this angle right here, and so then an angle BFC, which is this angle right here, comma, angle CFD, which is this angle right here, comma, and then and angle DFE, which are all the angles that make the straight line, right? So what relationship am I about to say? Are supplementary. Because remember, a supplementary angle relationship makes a straight line, or 180 degrees, okay? So now I have described or classified what I'm seeing. And so now I can use this description to create my equation. So if I'm using this description, that means I'm looking at all of the inside of these angles, and I'm saying if I add them up together, they should equal 180. So that would be x plus 36 plus 36 plus x equals 180. Okay, so what you seen me doing in the example, like on my notes, that now I'm about to do here, is another process of solving equations. It is specifically step 2, okay, which is known as combining like terms. So if I refer back to the example, right, I'm pretty sure some people are probably wondering, well, why we didn't just add 38 to 2x? You cannot add 38 to 2x because they are not like terms. What that means is that since 2 has the variable x, it is no longer a regular number like how 38 is, so they cannot be combined together because 2 has to know what x is to figure out what regular number it's going to be. And trying to add 38 to that would mess up the calibration of the relationship that 2 and x have, okay? So if we look at what we're dealing with now, our like terms would be the two 36s because they are both regular numbers or numbers without variables. And then we have two x's, which are the same variable, so they can be combined together. So x plus x would be 2x. 36 plus 36 would be a positive, so that would be plus 72 is equal to 180. Okay, so now we do the same process that they basically did in the example, where since this is a positive 72, to get rid of it, because now I have to isolate the variable to figure out what x is, to figure out what those measurements are, I would subtract 72 because now it becomes 0 and I can get rid of it. But to keep my equation balanced, I also have to subtract 72 on the other side. I still have 2x, which would be equal to 180 minus 72, which would be 108. Then just like before, to separate 2 and x, I would divide by 2, and x would equal 54. Okay, so now to do the last part where you're just filling in the angle measurements that you figured out, if x is 54, that means in these two blanks over here would be 54 degrees. I put a 4 at the top. Degrees. And the way you would check your work, right, if you want to check it to make sure, we know that all of these angles should add up to equal 180. So 54 plus 36 plus 36 plus 54. I know that 54 plus 36 is 90. So I know the other side is 90. 90 plus 90 is 180. Okay? So that is a rough example of what we're doing with this technique. So I can let y'all do number 2 because number 2 is also a straight line. But you can do that later and bring it back to me and see if it's done. I'm going to go ahead and do number 3 since number 3 is something different and something we haven't seen. So once again, if I read what they say about the figure, it says that ray BA, ray BE, ray BD, and ray BC all intersect at point B. So point B is right here, and they're talking about each line that's coming from each point, because remember, a ray is a line that goes in one direction from a point. Okay, just in case you don't know what a ray is, it's a line that goes in one direction from a specific point. All right, so now if I'm looking at them, right, I know that if I'm trying to describe the relationship I see, I can say that angle ABE, comma, so that's this right here, angle EBD, comma, that's this right here, and then finally, so and angle DBC, all right, have what relationship do you think I'm about to say? They are complementary because they are creating a right angle. Okay, so that means when I add all 3 of those angles together, they should equal 90 degrees. So with that being said, I should be able to write my equation, right? So that would be 18.25 plus x plus 34.5 should equal 90, okay? So just like I did before, I would combine my like terms on my things that are alike. So 34.5 and 18 should equal, so I know it's going to be 0.75. That'd be 2 carry the 1, so 52.75, and then that would be plus x because nothing happened to x, should equal 90. Then just like we did before, to get rid of something that is trying to add or subtract, right? This is a positive 52.75, so I would subtract 52.75. Y'all actually should remember seeing me do something like this in the example. So that means x would equal, borrow here, so it's 9, and 10. So that would be 5, 2 point, and then 7, 3. So I'm gonna write it a little better. X should equal 37.25. And then, to check your work, you would just make sure when you plug in this number for x that they all add up to equal 90. They should, because our work should be accurate and correct. So that means that this angle right here where x is should be 37.25. Okay. Once again, it's pretty easy. Like once you can identify your angle relationship, you should be able to, get it done and work it out. So we can skip number 4 because we can deal with fractions at a later time. But we can look at number 5, and then that'll be like kind of our last example that I do with you. After that, I want you to try your hardest to figure out what you can figure out with the angle relationships and what you've seen me do. Okay. So if we look at number 5, if we're just classifying it based off our definitions, we can already classify this as angles at a point, which means that they should all add together to equal 360, but we're kind of missing some angles, so we probably would need to figure some stuff out first before we can accurately get those measurements. Okay, so there's going to be multiple descriptions here that I use to figure this out, so follow me very briefly. So now here is a perfect example for me to show you what vertical angles look like. So here's our intersection, right? Across from each other are these two angles right here. They look like the same angle and are the same angle. So that means since this one is said to be 32 degrees already, that means if I was to solve this expression correctly, then that means it should also equal 32. So now the question is, how does that help me in the long run for what I'm doing? Well, since this expression has x in it, it can help me figure out what x is, so I can figure out what x is over here, or use x over here. So the angle relationship that I'm identifying in my description would be that angle BAC, which is this one, and angle FAE are vertical, okay? They are vertical, which means they should be equal. So I know that angle BAC is 8x plus 27, and angle FAC is 32. So now I can use this equation to figure out what x is, okay? So once again, we would get x by itself, so I have to subtract 27 first. All right, if I subtract 27, that's gonna leave me with 8x is equal to 32 minus 27 should be 5. And then I would divide by 8, okay, where x is equal to the fraction, because I don't want you to make it a decimal, 5/8. All right, so now that I know that x is 5/8, I can use x being 5/8 to figure out what the angle measurement of EAD is. So I hope you didn't write as big as me, because you might have to write this work down. So that would be 68 times. Okay, so I'm gonna go ahead and make it a fraction already, because fractions interact with fractions, times x, which is 5/8. You would have to multiply across. 68 times 5 is, let me retrieve my calculator. 68 times 5 equals 340. So that would be 340 over 8 times 1, which is 8. If we divide 340 by 8, that gives us 42.5. So that means this angle right there equals 42.5. So let me go through and label what I know. So this is 42.5. I know that this one is 32. Okay, so now that I have some solid numbers in, I can actually use even more angle relationships to continue to fill this out. So if you didn't notice, this is a straight line, correct, that is being split into two. So remember, when they're split into two, they still have a supplementary angle relationship, but that's also a linear pair, right? So I know both of them should add up to equal 180. I know one side's 32, so if I do 180 minus 32, I can figure out that this space right here is borrow 8, 4. So this should be 148 degrees over there. Okay, so you see how, okay, because I know it may seem like I'm doing a lot. You see how, I said 142? No, 48. No, yeah, 48. You see how I'm using multiple angle relationships to figure out multiple blanks. Okay, so now in the same way that I figured out that angle relationship because of a straight line, I could also do it again on the opposite side. I could say that these all should add up to equal 180, right? Which means if I add 32 plus 42.5 and then subtract that number from 180, I should be able to figure out what this is. But you could have also looked at the straight line that is BAE and said that if you once again do the exact same thing that I did with the other one I was looking at, add 32 plus 42.5 and then subtract that number from 180, I'll get that measurement. So let's go ahead and do that. I know that 32 plus 42.5 would equal 74.5. And if I take 180 and subtract 74.5, that should give me 5, 0, and 1, 105.5 in that angle measurement. Okay, so the most complicated one to do would be angles at a point, but if you notice, I broke it down into pieces. Like I looked and seen if there were easier methods and easier ways for me to figure out missing angles that required less work. Like you seen, I identified the vertical angle relationship first. Then once I identified that, I used that relationship to find X. Once I found X, that gave me the ability to figure out the things that were missing. And then after that, I looked for another angle relationship, which in this case, I found supplementary angle relationships, which means those angles added up to 180, and it allowed me to figure out what was missing. Okay, so that's basically in a nutshell what we're doing. Okay, like, so you can try to do number 6 and 7, even try to do number 8 if you want to. It should be preferably pretty easy if you like just take your time and break them down. I'll look over them in class, but that's it for today. Have a great